some basic reflexes and the ability to cry, the newborn is unable to perform many actions. Over the next 12 months, however, the infant becomes capable of sitting, standing, stooping, climbing, and walking. During the second year, while growth slows down, rapid increase in such activities as running and climbing takes place. It is important for educators and teachers to know about the physical and mental development of children at all stages because they spend maximum time with children during the day. It is important for them to know the normal physical and mental development of children during infancy because any small change or accident at this stage can have very serious consequences for the child's future. We will be looking at patterns of growth, physical growth and motor development, sensory and perceptual development, cognitive development, language development in today's lesson. Interesting? Fine. Let's start with the study of patterns of physical growth during infancy. Patterns of growth. During prenatal development and early infancy, the head occupies a big part of the total body. The earliest growth always occurs at the top, that is the head, with physical growth and differentiation of features gradually working their way down from top to bottom. The same pattern occurs in the head area, as the top part of the head, the eyes, and brain grow faster than the lower parts such as the jaw. Sensory and motor development generally proceeds according to the same top to bottom pattern. For example, infants see objects before they can control their body and they can use their hands long before they can crawl or walk. However, development does not follow a rigid order. One recent study found that infants reached for toys with their feet 4 weeks earlier on average than they reached for them with their hands. Growth also follows the proximodistal pattern, the sequence in which growth starts at the center of the body and moves towards the extremities. For example, infants control the muscles of their trunk and arms before they control their hands, and they use their whole hands before they can control several fingers. In the first few days of life, most newborns lose 5 to 7% of their body weight before they adjust to feeding by sucking, swallowing, and digesting. They double their birth weight by the age of 4 months and nearly triple it by their first birthday. Infants grow about 1 inch per month during the first year, reaching approximately 112 times their birth length by their first birthday. Growth slows considerably in the second year of life. At birth, the infant that began as a single cell has a brain that contains 86 billion of nerve cells or neurons. Amazing. Extensive brain development continues after birth through infancy and later. Because the brain is still developing so rapidly in infancy, the infant's head should be protected from falls or other injuries. At birth, the newborn's brain is about 25% of its adult weight, and by the second birthday, the brain is about 75% of its adult weight. However, the brain's areas do not mature uniformly. The infant's brain is literally waiting for experiences to determine how connections are made. Before birth, it appears that genes mainly directed how the brain establishes basic wiring patterns. After birth, environmental experiences guide the brain's development. The inflowing stream of sights, the sounds, smells, touches, language, and eye contact help shape the brain's neural connections. It may not surprise us then that depressed brain activity has been found in children who grow up in a deprived environment. Infants whose parents expose them to a variety of stimulation by talking, touching, playing are most likely to develop to their full potential. Physical growth and motor development. According to dynamic systems theory, infants assemble motor skills for perceiving and acting. Perception and action are joined together. In order to develop motor skills, infants must perceive something in the environment that motivates them to act and then use their perceptions to develop their movements. Motor skills represent solutions to the infant's goals. When infants are motivated to do something, they might create a new motor behavior. The new behavior is the result of many factors: the development of the nervous system, the body's physical properties, and its possibilities for movement, the goal the child is motivated to reach, and then the environmental support for the skill. For example, babies learn to walk only when maturation of the nervous system allows them to control certain leg muscles, when their legs have grown enough to support their weight, and when they want to move. Mastering a motor skill requires the infant's active efforts to coordinate several components of the skill. Thus, according to dynamic systems theory, motor development is not a passive process in which genes dictate the unfolding of a sequence of skills. The infant actively puts together a skill in order to achieve a goal within the constraints set by the infant's body and environment. Nature and nurture, the infant and the environment are all working together as part of an ever-changing system. Gross motor skills are that involve large muscle activities such as moving one's arms and walking. Newborn infants cannot voluntarily control their posture. Within a few weeks, though, they can hold their heads erect and soon they can lift their heads. By 2 months of age, babies can sit while supported on a lap or an infant seat, but they cannot sit independently until they are 6 or 7 months of age. Standing also develops gradually during the first year of life. By about 8 months of age, infants usually learn to pull themselves up and hold on to a chair, and by about 10 to 12 months of age, they can often stand alone. Locomotion and postural control are closely linked, especially in walking upright. To walk upright, the baby must be able to balance on one leg as the other is swung forward and to shift the weight from one leg to the other. Infants must also learn what kinds of places and surfaces are safe for crawling or walking. Whereas gross motor skills involve large muscle activity, fine motor skills involve finely tuned movements. Grasping a toy, using a spoon, buttoning a shirt, or anything that requires fingers to show more skill demonstrates fine motor skills. Sensory and perceptual development. Studying the infant's perception is not at all an easy task. Unlike most research participants, infants cannot write, type on a computer keyboard, or speak well enough to explain to an experimenter what their responses are to a given stimulus or condition. Yet, scientists have developed several ingenious research methods to examine infants' sensory and perceptual development. Visual preference method by Robert Franz. He made an important discovery. Infants look at different things for different lengths of time. Franz placed infants in a looking chamber which had two visual displays on the ceiling above the infant's head. An experimenter viewed the infant's eyes by looking through a peephole. If the infant was gazing at one of the displays, the experimenter could see the display's reflection in the infant's eyes. This allowed the experimenter to determine how long the infant looked at each display. Fans found that infants only 2 days would gaze longer at a patterned discs than at red, white, or yellow discs. Similar results were found with infants 2 to 3 weeks old. Habituation and dishabituation. Another way that researchers have studied infant perception is to present a stimulus a number of times. If the infant decreases its response to the stimulus after several presentations, it indicates that the infant is no longer interested in the stimulus. If the researcher now presents a new stimulus, the infant's response will recover, indicating the infant could discriminate between the old and new stimulus. Newborn infants can habituate to repeated sights, sounds, smells, or touches. They love repetition. Among the measures researchers use in habituation studies are sucking behavior, heart and respiration rates, and the length of time the infant looks at an object. Just how well can infants see? Ever wondered? The infant's color vision also improves. At birth, babies can distinguish between green and red. All of the eye's color sensitive receptors function by 2 months of age. Newborns are especially sensitive to human speech and sounds. Just a few days after birth, newborns will turn to the sound of a familiar voice. Have you seen when the mother speaks, immediately the head turns? So, by 2 years of age, infants have considerably improved their ability to distinguish sounds with different pitches. Newborns respond to touch. A touch to the cheek produces a turning of the head. A touch to the lips produces sucking movements. Newborns can also feel pain. Newborns can differentiate odors. The expressions on their faces indicate that they like the scents of vanilla and strawberry but do not like the scent of rotten eggs or fish. Sensitivity to taste might be present even before birth. At about 4 months of age, infants begin to prefer salty tastes, which as newborns they had not liked. Cognitive development. Piaget's theory is a story of how biology and experience help in cognitive development. Piaget thought that just as our physical bodies have structures that enable us to adapt to the world, we build mental structures that help us to adapt to the world. How wonderful! Adaptation involves adjusting to the new environmental demands. Piaget stressed that children actively construct their own cognitive worlds. Information is not just poured into their minds from the environment. What processes do children use as they construct their knowledge of the world? Piaget developed several concepts to answer this question. Schemas. As the infant or child seeks to construct an understanding of the world, the developing brain creates schemas. These are actions of mental representations that organize knowledge. In Piaget's theory, infants create behavioral schemas, whereas toddlers and older children create mental schemas, that is, cognitive activities. A baby's schemas are structured by simple actions that can be performed on objects such as sucking, looking, and grasping. Older children's schemas include strategies and plans for solving problems. Assimilation and accommodation. To explain how children use and adapt their schemas, Piaget offered two concepts, that is, assimilation and accommodation. Now, assimilation occurs when children use their existing schemas to deal with new information or experiences. Accommodation occurs when children adjust their schemas to take new information and experiences into account. Organization in Piaget's theory is the grouping of isolated behaviors and thoughts into a high-order system. Continual refinement of this organization is an inherent part of development. A child who has only a vague idea about how to use a hammer may also have a vague idea about how to use other tools. Equilibration and stages of development. Assimilation and accommodation always take the child to higher ground according to Piaget. In trying to understand the world, the child inevitably experiences cognitive conflict or disequilibrium. That is, the child is constantly faced with inconsistencies to his or her existing schemas. For example, if a child believes that pouring water from a short and wide container into a tall and narrow container changes the amount of water, then the child might be puzzled by where the extra water came from and whether there is actually more water to drink. The puzzle creates disequilibrium. For Piaget, an internal search for equilibrium creates motivation for change, and that's how they learn. The child assimilates and accommodates, adjusting old schemas, developing new schemas, and organizing and reorganizing the old and new schemas. Eventually, the organization is fundamentally different from the old organization. It becomes a new way of thinking. Equilibration is the name Piaget gave to this mechanism by which children shift from one stage of thought to the next. Equilibration does not happen all at once. There is considerable movement between states of cognitive equilibrium and disequilibrium, and assimilation and accommodation work in concert to produce cognitive change. A result of these processes, according to Piaget, is that individuals go through 4 stages of development. A different way of understanding the world makes one stage more advanced than the other. Cognition is qualitatively different in one stage compared with another. In other words, the way children reason at one stage is different from the way they reason at another stage. Language development. Babies actively produce sounds from birth onwards. The effect of these early communications is to attract attention, and when the babies make such sounds, it's really attracted, isn't it? Babies' sounds and gestures go through this order during the first year. Crying. Babies cry even at birth. Crying can signal distress, but there are different types of cries that signal different things. Cooing. Babies first coo at about 1 to 2 months. These are gurgling sounds that are made in the back of the throat and usually express pleasure during interaction with the caregiver, mostly the mother. Babbling. In the middle of the first year, babies babble, that is, they produce strings of consonant vowel combinations, such as they go on ba 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 ba. Have you heard? Wonderful, right? Gestures. Infants start using gestures such as showing, pointing at about 8 to 12 months of age. They may wave bye bye, not to mean yes, and show an empty cup to want more milk. Long before they begin to learn words, infants can make fine distinctions among the sounds of the language. Between about 8 and 12 months of age, infants often show their first understanding of words. The infant's first spoken word is a milestone eagerly anticipated by every parent. This event usually occurs between 10 to 15 months of age and at an average of about 13 months. However, long before babies say their first words, they have been communicating with their parents, often by gesturing and using their own special sounds. The appearance of first words is a continuation of this communication process. A child's first words include those that name important people like Dada, or familiar animals, they say kitty, or vehicles, the car, the toys, food, body parts, clothes, household items like the clock, and greeting terms. On the average, infants understand about 50 words at about 13 months, but they can't say this many words until about 18 months. Thus, in infancy, receptive vocabulary exceeds spoken vocabulary. The infant's spoken vocabulary rapidly increases once the first word is spoken. So, it's like starting trouble. Whereas the average 18-month-old can speak about 50 words, a 2-year-old can speak about 200 words. This rapid increase in vocabulary that begins at approximately 18 months is called the vocabulary spurt. In Growing Up with Language, linguist Naomi Baron provided ideas to help parents facilitate their child's language development. So, let's see some tips. Be an active conversational partner. Talk as if the infant understands what you are saying. Use a language style with which you feel comfortable. Don't worry about how you sound to other adults when you talk with your child. So, let's conclude. So far, we have seen that it is important for infants to get off to a healthy start in their journey through life. Unfortunately, this doesn't happen for some children whose circumstances place them at risk for development problems. The first problem in the development of infants in a developing country like India is that of nutrition, a major problem. Many children born in poor families in India do have access to the right kind of food and develop physical and developmental problems due to malnutrition. The other problem in the development of infants is the mental atmosphere or climate around the child is not healthy or even abusive at times. Of late, we are hearing about many social problems in Indian families like alcoholism, wife beating, and dowry related problems. Such problems also affect the mental development of the child because a child makes mental structures out of the behavioral of the adults around him or her and carries these mental structures well into adulthood and even old age. So, it affects for a long period. So, it's really important that the correct mental and physical conditions should be given to the infant at the beginning of his or her life in order that they may have the correct physical and mental development.